one that has only income in it. So we have the quantity of bread on the left, income on the right. In the more general model, we have income, family size, the price of bread, and the price of meat. So estimate those two. And in the first only income matters model, test the null hypothesis that the angle curve for bread is homogeneous against the alternate that families have some committed quantity of bread, which they will purchase regardless of family income. Nan-Chin, are you an econ student? No. Who are the econ students? Now you're afraid to raise your hands. What's an angle curve? Ron? That's the income consumption curve from which you would derive an angle curve. Okay, you may remember from principles of micro or intermediate micro that if you have a set of isoquants and you change the household income and plot their optimal choices of bread and meat, you get a ray through the meat-bread plane. And that ray that connects the optimal choices is an income consumption curve. And then if you write those down, you can graph the angle curve from them. So we want to know whether or not the angle curve for bread is homogeneous against the alternate that families have some committed quantity of bread which they purchase regardless of family income. What do we mean by Nan-Chin? Even though you're not an economist, you might know what we mean by homogeneity in this context. It might be apparent from the way the null hypothesis is set up. It means that your consumption of bread is increasing in proportion to income, and it's the same proportionate increase all the time. It's like when you test for returns to scale in a production function. You examine the degree of homogeneity in the inputs. So the first question is to see whether or not in that simple linear model the intercept is 0 against the alternate that it's not. So that, of course, is a simple t-test. It's no big deal. Oh, the estimated results are here, and the observed t-statistic is, scroll things up a little bit. The observed t-statistic for the first question is that mu is equal to 0 against the alternate that mu is greater than 0. It doesn't make any sense for mu to be less than 0. You can't have a negative committed quantity of bread consumption unless you're bulimic or something. So the observed t is 2.32, and the probability of getting an observed t, or the critical value is, and that cuts off, that encloses 97% of the probability distribution, so certainly at the 5% level you would reject the null households of a committed quantity of bread that they have to consume.
And in this case, mu is the intercept. Right?
Yeah, mu is the intercept. Incidentally, is it possible to derive a linear demand curve from any known utility function and preserve all the stipulations regarding symmetry and homogeneity and all the rest of that stuff? No, can't do it. So in spite of the fact that your econ theory book talks about integrability and duality, in practice the way we implement things in the real world out with real live data is in contravention of just the basic tenets of what goes on in your theory books. So let's take a look at the questions in number 3. Question 3 says, in the second model, where we have the prices and income and family size, test the following hypotheses. Family size and bread and meat prices are not significant influences on bread consumption. So the null hypothesis is that is the joint test of hypothesis that either family size or the price of or the price of bread or the price of meat are 0. And we would reject the null if any one of those restrictions is violated. There's a difference between testing them jointly and constructing the 3 t-statistics. Okay, so if this was an exam question and you produced 3 t-statistics for me, I'd mark you wrong because the null hypothesis is stated as a joint test of hypothesis. Yeah, so it's an F test. And in 3b, conditional on your rejection of the above hypothesis, test whether or not the price of meat is a significant factor in determining bread consumption. So the first one is an F test, and so the null hypothesis is that gamma is equal to beta b, is equal to beta m, is equal to 0, and the alternate is that at least one is not 0. Of course, we could look back at the results that we got from running the estimation routine And these are t-statistics written underneath. And you know before you even construct the f-test that you're going to reject the null, because all the t's are different than 0. But we'll go through the exercise anyway of constructing the f-test. So S little omega is the residual sum of squares for the restricted model. That's the model with only income and the intercept. And S big omega is the residual sum of squares for the unrestricted model, the model with income, family size, price of bread, price of meat. You know. So that your F statistic is the restricted sum of squares, which is always bigger, minus the unrestricted sum of squares over the number of restrictions, which was 3, divided by the unrestricted sum of squares divided by its degrees of freedom. So we have an observed F of 26.2. That's huge. You don't even need to look that up in the table. That's gigantic F statistic. So we rejected all hypothesis that all 3 coefficients are 0. That's the ultimate, that one or more of them is not.
So the idea here is that the price of meat was going so fast that people were substituting.
We haven't gotten to that part yet. That's yet to come. That's a little more complicated. We're just warming up with these questions.
So what is the problem?
So this tells us that the price of bread, price of meat, and family size all matter. At least one of them matters, is what it tells us more specifically. In the second part, we construct the observed t-statistic for meat, the price of meat, and the observed t is 3.53, and so you conclude that the coefficient on the price of meat is different from 0. And actually, I guess I'm pretty sloppy here. I'm not even paying attention to signs. Cool. Oh, this is the quantity of bread. The quantity of bread is on the left. The price of meat is on the right.